Hi everybody. I've been spending the day writing code to show to my Swift class that I teach about how to handle strong reference cycles and avoid them by using weak and unknown reference declarations in your code. The final thing I did was make a drawing about capture lists and how to deal with them and how to deal with strong reference cycles between instances and their closure properties, and I thought I'd share it with the internet. Here we are. So I have a person instance here, and it has two properties. It has a name property that has a value of Mike, and has a closure property, and it has this closure in it. The closure sets the name property on the person instance to the string Jim. When it sets that property, it captures the self instance and makes a strong reference to it. Now, closures are reference types, which means that when you assign a closure to a closure property on the person instance, you're already establishing a strong reference from self to closure. So when you capture self, when you access the name property or any other property on the person instance from inside the closure, it's going to establish a strong reference, a second strong reference from closure to self. That can happen at one of two times. If you've declared the property to be lazy, that will happen the first time the property is accessed. If it's a normal property, let's stretch that out. Then the second strong reference will be established when the class is initialized and the closure is assigned to the property. So there is a remedy known as a closure list. So the problem is self is implicitly defined as strong, just as any property that doesn't have a weak or unknown modifier is also a strong property. And so you create something called a capture list to modify the reference to self into being either a weak or unknown. And the rules are pretty much the same. You use weak when the reference to the person instance in the code enclosing the closure is nilled out. The closure, because it's a weak reference to the person instance, won't prevent the person instance from being deallocated. Okay? So if you have an unowned reference, it's the same as if it's an unowned property. You do it when you expect the person instance not to be nilled out, or you expect both of these instances, the closure instance and the person instance, to be deallocated at the same time. Okay? So there, I hope that drawing helps.